Next is question number 43, where it is given that integral of 0 to pi by 2 dx divided by 4 cos square x plus 9 sin square x whole square is equal to 13 pi by lambda. The sum of the digits of lambda. Basically, we have to find the value of this integral. So, before finding the value of this integral, let us consider another integration, that is 0 to pi by 2 dx upon a square cos square x plus b square sin square x. We will not take square here, right? We directly know the formula of this integral, that is equal to pi upon 2ab. How can we find it? We will divide in the numerator and denominator by cos square x, and in the denominator we can put tan x equal to t. So in the numerator secant square x into dx will be equal to dt. So this can be solved very easily. So this is equal to pi upon 2ab. Now if I differentiate it with respect to a, so what will we get? We will get 0 to pi by 2 2a cos square x into dx divided by a square cos square x plus b square sin square x whole square multiplied with minus 1. Similarly, on the right hand side, when we differentiate it with respect to a, so we will get minus pi upon 2a square b. So it can be observed that minus from both sides will get cancelled. So we will get integral of 0 to pi by 2 cos square x dx divided by a square cos square x plus b square sin square x whole square is equal to, taking 2a in the right hand side, we will get pi upon 4a cube b. Now in the similar fashion, if I differentiate it with respect to b, we will get 0 to pi by 2 sin square x multiplied with dx, and in the denominator we have a square cos square x plus b square sin square x whole square is equal to pi divided by 4b cube a. Right? Now if we add both of these 1 and 2, so we will get 0 to pi by 2 sin square x plus cos square x in the numerator can be written as 1. So we get dx divided by a square cos square x plus b square sin square x whole square is equal to pi divided by 4ab can be taken common. We have 1 by a square plus 1 by b square. Now we have to find the value of the similar thing, where the value of a can be put equal to 2 and value of b can be put equal to 3. So we will get the value equal to pi divided by 4 times 6, that is 24, multiplied with 1 by 4 plus 1 by 9. So that will be equal to pi by 24 into 36, 13. So this is equal to 13 pi divided by 864. So we can say that the value of lambda is equal to 864. So the sum of the digits of lambda will be 10 plus 8, that is 18. So the answer of this question will be 18. Next is question number 44. The circles C1, C2, C3 with radii 3, 3 and 1 respectively touch each other externally. If R1 and R2 are the radii of two circles touching each of the circles C1, C2 and C3, then we have to find the value of R1 into R2. So let us take the circles on the coordinate axis, where this is one circle, this is another circle, and third circle is this one, right? Let us say these are the three circles and radius of these two are 3. So the point is 3, 0 and this point is, let us say P minus 3, 0. Let us say this point is Q. Now we are given two circles which touch all these three circles. Let us say this is one of the circle that is touching all these three circles and the other one is this one, right? This is how the curves will be. Now let us take the center of the bigger circle as 0, K and let this point be S, right? This is the center of the bigger circle. Now we can write PS is equal to under root of OP square, that is 9, plus OS square, that is K square. Let us say its radius is R1. Now PS can also be written equal to R1 minus radius of the circle with center P. So we'll get R1 minus 3. Now also let us write SQ. SQ will be equal to under root of, let us say the coordinate of Q is 0, A. So PQ square will be equal to 9 plus A square. Also PQ square can also be written equal to radius of the circle with center P, that is 3, plus radius of circle with center Q, that is 1 whole square. So we can say that 16 minus 9, that is 7, is equal to A square. So the value of A is equal to minus root 7. So let us write it here equal to 0, minus root 7. This is the coordinate of Q. Now SQ can be written equal to K plus root 7. Also it can be written equal to radius of bigger circle, that is R1 minus 1. So from these two equations, if we eliminate K, we can find the value of R1 as 5 plus 2 root 7. Now in the similar pattern, we will find the radius of the smaller circle. Let's say its center is S dash, that is represented by 0, T. So we will find S dash P, that will be equal to sum of the radius of both the circles. Let us say radius of the smaller circle is R2. So it will be equal to R2 plus 3. Also it can be written equal to under root of OP square, that is 9, plus OS dash square, that is T square. Also we can find in the similar manner the value of S dash Q, that will be equal to T plus root 7. Also it can be written equal to sum of the radii of both the circles, that is R2 plus 1. So from these two equations we will find the value of R2, that will be equal to 2 root 7 minus 5. So multiplying R1 and R2, we can find the value will be equal to 4 times 7 minus 25, that is 28 minus 25, that is 3. So answer of this question will be 3. Next is question number 45, which says that if alpha and beta are the values of k for which the roots of equation x cube plus 6x square plus kx minus 8 equal to 0 are in AP and GP respectively, then we have to find the value of alpha minus beta. Now here let us assume that the roots are in AP and the roots are A minus D, A and A plus D. So we can say that the sum of roots will be 3A and the sum of roots is equal to minus 6, which means that A is equal to minus 2. Now as it can be seen that A is a root of the equation, so A equal to minus 2 will satisfy the equation. So let's put it here. So we'll get minus 8 plus 24 minus 2k minus 8 is equal to 0, which means that 24 minus 16, that is 8, is equal to 2k, that is the value of k is equal to 4, that is the value of alpha is equal to 4. In the similar manner, let's find the value of beta. Let us say the roots are in GP and the roots are A by R, A and AR. So product of roots is A cube, that is equal to 8, which means that value of A is equal to 2. So it will satisfy the given equation. So let us put it back. So we'll get 8 plus 24 plus 2k minus 8 is equal to 0, which means that 2k is equal to minus 24, that is value of k is equal to minus 12, that is the value of beta is equal to minus 12. So we can say that the value of alpha minus beta is 4 plus 12, that is 16. So answer of this question is 16. Next is question number 46, which says that if cos 4 degree into cos 8 degree and so on up till cos 88 degrees is equal to 2 raised to the power minus n, then we have to find the value of n. Now we know the formula that 4 into cos a into cos 60 minus a into cos 60 plus a is equal to cos 3a. So we will make use of this formula here. So let us write cos 4 degrees into cos of 56 degrees into cos of 64 degrees in one bracket, multiply by cos 8 degree into cos of 52 degree into cos of 68 degrees in another set, and so on. We will write it up to cos of 28 degrees into cos of 32 degrees into cos of 88 degrees, and cos 60 degrees will be left aside. Right? Now, writing it as the given formula, this can be written equal to 1 by 4 times cos 12 degree. From here we will get 1 by 4 times cos of 24 degrees, and so on. We will get up to 1 by 4 times cos of 84 degrees, and cos 60 degrees can be written as 1 by 2. So this is equal to 1 by 4 raised to the power 7 multiplied with 1 by 2. Next we have cos 12 degree. So again, accumulating these terms, we can write it as cos of 48 degree into cos of 72 degrees multiplied with cos 24 degrees, cos 36 degrees multiplied with cos of 84 degrees into 1 by 2 again for cos 60 degree. So this is equal to 1 by 2 raised to the power 20 into cos of 36 degrees into cos of 72 degrees. Now the values of these can be directly put, that is root 5 minus 1 upon 4 multiplied with root 5 plus 1 upon 4. So this is equal to 1 by 2 raised to the power 22. So we can say that the value of n is equal to 22. So its answer is 22. Next is question number 47, which says that let f be a differentiable function for all x belonging to R such that this equation is given and f dash 0 is given to be equal to 3. So we have to find the value of f of ln 2. Now we are given f of x plus y equal to e raised to the power y into fx plus e raised to the power x into f of y. So here if I put x and y both equal to 0, so we'll get f0 equal to 2 times f0, which means that the value of f0 is equal to 0. Also, if I differentiate it with respect to y, so what will we get? F dash x plus y is equal to e raised to the power y into fx. We are doing partial differentiation, that is we are keeping x as constant, plus e raised to the power x into f dash y. Now here put y equal to 0, so we will get f dash x equal to fx plus e raised to the power x into f dash 0, that is given to be equal to 3. So we get dy by dx minus y equal to 3 times e raised to the power x. So this is a linear differential equation where integrating factor is equal to e raised to the power integration of minus 1 into dx, that is equal to e raised to the power minus x. So the solution of this differential equation is y times integrating factor, that is e raised to the power minus x, is equal to 3 into e raised to the power x multiplied with e raised to the power minus x. So we have to do integral of 3 into dx plus constant. So we will get y into e raised to the power minus x equal to 3x plus constant. So putting x equal to 0, we will get y as 0. So we can say that the value of constant is equal to 0, which means that y is equal to 3x multiplied with e raised to the power x. Now we have to find the value of f of ln2 upon ln2. So that will be equal to 3 multiplied with 2, that is 6. So answer of this question is 6. Next is question number 48, which says that if two curves C1, that is mod x minus mod y, whole mod equal to 1, and C2, that is an ellipse, x square upon 2 plus y square upon b square equal to 1, intersect at 6 points on the xy plane, and E is the eccentricity of C2, then the value of 8 upon E square is. Now here, firstly, it can be seen that this curve C1 is symmetric about both x-axis and y-axis. So we just have to plot the graph in first quadrant, and then we will take its mirror image to draw it in all the 4 quadrants. In first quadrant, mod x will be x, mod y will be y. So C1 is x minus y whole mod equal to 1, that is x minus y is equal to plus minus 1. So the graph in first quadrant will be like this one, where this point is 1, 0 and this point is 0, 1. So taking its mirror image in all the 4 quadrants, we will get the graph as this one, right, where this point is minus 1, 0 and this point is 0, minus 1. Now it has been given that the another graph, that is an ellipse, it is intersecting it at exactly 6 points, as it will be passing through plus minus root 2, 0. So it will intersect at exactly 6 points if the ellipse is like this one, right? This is the only case, which means that value of b square will be equal to 1, and a square is already given to be equal to 2, so we have to find its eccentricity, that will be equal to 1 minus 1 by 2. So value of e square is 1 by 2, which means that the value of 8 upon e square, that will be equal to 16. So answer of this question is 16. Next is question number 49, which says that if a and b are two of the real numbers satisfying the equation sin inverse 2x upon 1 plus x square plus cos inverse 1 minus x square upon 1 plus x square equal to 0, and mod of 3a minus 7b is less than k for all possible values of a and b, then the least integral value of k is what we have to find. The question can be easily solved by making the graph of sin inverse 2x upon 1 plus x square, which is a standard graph. Its graph will be something like this, where this point is 1, 0 and this point is minus 1, 0. Similarly, we can make the graph of cos inverse 1 minus x square divided by 1 plus x square. That will be like this, where this point is 0, pi. So this is the graph of cos inverse 1 minus x square divided by 1 plus x square. Now it has been given that the addition of these two is equal to 0, which clearly means that x belongs from minus 1 to 0. Now a and b takes the values in this interval, which means that mod of 3a minus 7b, its least value is 0 and its maximum value will be 7. So it will belong from 0 to 7. Now in the question it has been given that it is less than k, and we have to find the least integral value of k, so that will be definitely 8. So answer of this question is 8. Next is question number 50, which says that let fx is equal to e raised to the power x for x less than 0, minus x minus 1 for x going from 0 to 1, and 2x square for x greater than 1. Similarly, a function gx is also given. Now we have to find the number of points of discontinuity of fx, and we have to find the number of points of discontinuity and non-differentiability of gx. So let us start it. Now we can see for fx at 0 minus the value is tending to 1, and for 0 plus the value is tending to minus 1, which means that fx is discontinuous at x equal to 0. Now let's check at x equal to 1. At 1 minus the value is minus 2, and at 1 plus the value is 2. So it is discontinuous at x equal to 1 also. So we can say that the value of n is equal to 2. Also for gx we have to find the points of discontinuity. Firstly, let's find the function gx, that is equal to 1 upon e square for x less than minus 2. Now mod of fx, that is it is equal to e raised to the power x for x going from minus 2 to 0, and it will be equal to x plus 1 for x going from 0 to 1, and it will be equal to 2x square for x going from 1 to 2, and it is x cube minus x square plus 4 for x going from 2 to infinity. Now for discontinuity, let us check it. Minus 2 minus the value will be 1 upon e square. For x equal to minus 2 plus the value will be e raised to the power minus 2, that is equal to 1 by e square. So it is continuous at x equal to minus 2. Now at 0 minus the value is 1, and at 0 plus the value is also 1, so it is continuous at 0 also. At 1 minus the value is 2, and at 1 plus the value is again 2, so it is continuous here also. At 2 minus the value is 8, and at 2 plus the value is 8 minus 4 plus 4, that is again 8. So it is a continuous function for all x belonging to R. So we can say that the value of m is equal to 0. Now we have to check the points of non-differentiability. Now for x less than minus 2, the slope will be 0. For x going from minus 2 to 0, the slope is e raised to the power x. For x going from 0 to 1, the slope is 1. For x going from 1 to 2, the slope is 4x. And for x going from 2 to infinity, the slope is 3x square minus 2x. Now let's check the points of non-differentiability. At minus 2 minus, the slope is 0. At minus 2 plus, the slope is e raised to the power minus 2. That is, it is non-differentiable at x equal to minus 2. Now at x equal to 0 minus, the value is 1. At 0 plus also the value is 1, so it is differentiable. At 1 minus the value is 1. At 1 plus the value is 4. So it is non-differentiable at x equal to 1. At 2 minus the value is 8, and at 2 plus the value is 12 minus 4, that is again 8. So it is non-differentiable at 2 points, which means that the value of R is equal to 2. So the value of Mn plus Nr plus Rm will be equal to 4. So answer of this question is 4.